Also, before I get going, shout out, thanks to Blue Cross Blue Shield for hosting it. One of the top 2 places I'd say that we host at. So thanks a lot. So actually last night, I was planning on doing a dry run on my presentation just to make sure I was all ready. However, I had all of my files up in GitHub, and GitHub was down all last night from like 6:30 until about 9 o'clock. So I didn't get to do that run through of it last night.
DSO was up.
It probably was. So yeah, cloud is great, but there are frustrations that occasionally come with being in the cloud. Speaking of that, how many here are hosting either an application, either a personal application or one through your work in the cloud, either Azure cloud or Amazon's cloud or any of the other clouds? Okay, see a few hands out there. I guarantee if I ask that same question a year from now, there'll be even more, because that's just the trend that it's going. More and more moving it off-site, out of your data center, into the cloud. And that actually opens up a lot of opportunities for companies. There's a lot of really cool stuff that exists out in the cloud that you don't have access to in your data center. So certainly an awesome trend. We're going to be talking about Azure's cloud. And here you can see I threw up, I went out to, actually this came from Azure's billing page. And this is all the services that they have in their cloud. And I mean, you can see there's quite a bit broken into multiple categories here. We're going to be talking just about that one that's highlighted. You know, so just a small fraction of what Azure offers. But, and you can see it, every time I go out there, I'm seeing something new service that they're offering. Like I noticed this Store Simple. I don't even know what Store Simple is, but I know it wasn't on there last time I looked. So it's like they're constantly adding new products, new capabilities to their cloud. So really exciting times. Storage is, I'd kind of call storage a foundational aspect to the Azure cloud. A lot of the features that you see on here are actually built on top of Azure storage itself. So like if you start up in the top left hand, the VMs, both of those use Azure storage for storing their hard drives on there. It's just a great tool for them to use, and great tool that you can leverage for your own applications too. So let's talk about the storage landscape. There are 3 parts to the storage. This slide here covers things that are true, common between all 3. So there's libraries for .NET, including the upcoming .NET Core. Recently just got changed to .NET Core. It was, I don't know what they're calling it, but apparently the official name is .NET Core. Node.js, Python, Java, Ruby, PHP, C++. Those are the ones that Microsoft has official libraries for. So Microsoft's going out there, putting together these libraries, vetting them, putting them out there for languages that 5 years ago we would have thought as competing with Microsoft. And now, you know, I think Microsoft's new motto is we don't care what you're doing as long as it's running in our cloud. So so they're certainly making every effort to get out there and bring in all these other tools. If your language isn't listed, they also have a REST API for everything that we're going to talk about tonight. We won't talk about the REST APIs, but they're there. A lot of their .NET APIs are actually talking over that REST API, so it's not doing anything magical that you can't do yourself. There's another common concern when you start going to the cloud is security. Am I going to put it out there and folks can steal my data? One of the demos that we have covers security, and you'll see that there's a lot of security options that you can have, all the way from putting it out there so it's totally public that anybody can see it and put files in there, to lock down where you're the only one that can see it. Encryption options are available. I haven't worked with the encryption options much with the Azure storage, but from my understanding is they are kind of a little bit more, you're doing it yourself. So you're encrypting your items before you're putting them in there. However, they do have the Azure Key Vault. And Azure Key Vault is basically a place to store secrets. And it's a secure place to store secrets. You can utilize their APIs with the Key Vault to manage your encryption and whatnot. And finally, storage, the stuff that we're going to talk about is in Azure data centers all over the world. I remember when Azure first started springing up and there was just East and West. And now it's East, West, East, West 1, East, West 2, North, South. I mean, European, Chinese, they probably have a data center within 100 miles of you by now. So it's growing, it's out there, definitely worth looking into. So the first aspect of Azure storage that we're going to talk about is Azure Table Storage. It's one of 3 storage models that they have. Table storage is basically just storing your data in columnar data. So think an Excel spreadsheet. Much cheaper than storing in a database. The link that I have there is from a site. It's called Have I Been Pwned? And basically he's a security researcher, and what he's done is he goes out for every one of these security breaches that happens, and he gets the list of all the emails that were lost in the breach, all the information in it, and he's putting it into his database. And he has a web interface on there where you can search, you type in your email, and they'll tell you if your information was included in any of those data breaches. Mine was in the Adobe hack a few years back. And he's kind of interesting. A lot of people don't talk about how they're working with the tools. He's really open about how he's working with the tools. So he's got a series of articles about how he's storing it in Azure Table Storage. And in there, he makes the comment that by his calculations, if he were to take his data and store it all in a SQL database, in Azure SQL database, it would cost him 22 times more than what it's costing him to store it in Azure Table Storage. And so you can see there's a fantastic savings there. If I remember right, the number that he throws out there that he's saying his average monthly cost is $100. And that's for the web hosting he does have a SQL database in there, but if you picture what that becomes if you're multiplying it by 22 times, that he's able to deliver this service efficiently, quickly, by leveraging the tools available. So,
Do you know why it's so cheap?
why it's so cheap?
Yeah. Versus SQL.
Well, it's not a full relational model. There are some limitations that we're gonna cover here in a little bit, but I think it's just more architected for being distributed. Using tables. So we have this slide, and then we'll look at a little bit of code. Using Azure Table Storage does come with some limitations. And there are limitations that you can get around if you think about your data, but there are limitations. You only get 2 indexes, and you can't really, you have to use those indexes, and they kind of dictate how you use those indexes. The 2 indexes are partition key and row key. The combination of these 2 must be unique for every record. Partition key, if you think about a big old box, partition key is going to be that box, and every record inside of there is going to have a unique row key. So that's how you partition out your database. And that also kind of goes into how the different types of queries factor into there. So most efficient query is going to be partition key equals something and row key equals something. So if you picture that box, if I know exactly what box it's in and exactly what ID it is, I can find it right away, and it's nice and cheap to get it. Next most efficient is partition key is X and row key is between Y and Z. So there, I'm starting on the right box, but I have a stack and I know it's going to be in between here and here, and I can just grab that pile of stuff. Next most efficient, and at this point we're really starting to get into some inefficient ways to gather your data. Next most efficient is partition key. I know what the partition key is, but I don't know what my row key is, but I do know what one of those other column values are. And when that's the scenario that I have, you're basically paging through every single record in that partition. You don't have to look at all the other partitions in your storage, but in that partition, you're looking through every single record. And worst is not including the partition key. Either just saying I have this row key or I have this column value. And then you're looking through every single box that you have for that record. Any questions on partition keys, rows keys? They are string values. You can also, I talk about this a little bit down in the think outside the box. You can be flexible on what those string values are. So in one solution that I was working with, I had multiple data types stored in there, and I wanted them on a daily series. And so I actually serialized the day into year, month, day, dash the data type, and that was my partition. So it was kind of a compound key that I was using for my partition key. Atomic operations are performed via entity group transactions, and entity group transactions can only be performed with entities in the same partition. So if you think about transactional boundaries, they all have to be in that same box in order to participate in one transaction. And so that could determine how you structure your model and whatnot. Thinking outside the box. Now this is where some of the real power of the table storage comes into play. You can store multiple entity types in the same table. So I can have widgets and things in the same table. Now every DBA's head just probably exploded by saying that, but you can store multiple things in there. They can even have different shapes, so they don't all have to have the same column names. They can have different column. As you're trying to, a lot of times you're going to want to denormalize your data. So you don't have joins that you can do to pull across values from multiple tables. You're going to want to denormalize that, flatten it out, and so that you can get it with one table query. You certainly can. If you have data that fits across multiple tables, you can make multiple queries to them, but you don't have that nice joining capability that you have in like a SQL Server solution. Compound values for partition key and row key, that's where I talked about merging two values together to generate your unique values. The other one you'll see quite often, storing multiple copies of your data projected to how you're going to use it. So if we go back to the way that some of those queries are, maybe in one case I want to pull date, or I want to pull my data all based on this particular day, and maybe other times I want to pull it on a different axis where I want to pull it all of this particular type of data. In that case, it may be more efficient to actually store two copies of my data, and then each one is projected so that I can do those highly efficient partition key, row key queries against my data. Of course, if you're going to store multiple copies, it's expected that you're going to have to manage that, and it's going to take up more space too. But keep in mind, 22 times more expensive to go to SQL Server. So, so you have that option. Let's look at some table code. I have two projects, and actually both of them have table. So this first file, or this first one is not there. Yeah. I don't know what the mirror hotkey is, and it's not labeled on here, so. Windows key P. There we go. All right. Okay, so this first example, we're going to come back and visit it throughout all of the tools that we're going to talk about. Let me make sure I'm on the right one, and I'm not. So we're gonna come back and we're gonna visit this tool for each of the table types. Basically, what we're going to be looking at is a tool that has a console-based application that uploads images to Azure Table Storage, and then there's a web application that displays those images for us. So first thing, before we get into code, one of the tools, if you install the Azure SDK, that you have access to is a table storage emulator tool. This table storage emulator tool is, that's not the right, so table storage emulator allows you to run a local copy that looks and behaves like the real copy up in Azure. Now, it's not the exact same software that's running. For one thing, this is running on a single computer, whereas the one in Azure is spread out. Your data may end up across 1,000 different servers. But this is a nice tool that you can use to develop against and test against without actually having to go to the cloud. Real nice when you're projecting and you don't want to, or when you're presenting and you don't want to depend on your host's internet connection. So the tool is pretty simple. It's command line based, although there is a little task icon that shows up once we get it started. Initialize the storage emulator is basically going to create my sandbox. It's running on SQL or on Microsoft SQL Server, so it's going to go out and create the data schema and everything that it's going to run against for me. I have already initialized this one, but I do want to clear this one to remove any of my test data. So there I basically just wiped out every record that I had in the storage emulator from when I was testing and whatnot, so that we'll get a brand new fresh slate. And just like that, our testing storage emulator has started. We get this handy dandy little icon down here that that I hid and go away. Gives you, well, normally it gives you information about it. Maybe it is here. All right, that part doesn't matter. I normally end up just sticking to the command line just because I kind of like the command line tool. So we've got our storage emulator. Now, my application, first step that we're going to look at is working with table storage. So what we're going to do is I have this get files to save, and I just hard-coded a collection of all the files that we're going to upload there, and put a breakpoint on it here, and let's step into.
Will you zoom in a bit?
Is that better? All right. So first thing you'll notice in just about everything that I'm using Async Calls. Isn't really specific to the Azure storage stuff, but I think my personal opinion is Async is a game changer when you're talking about these sorts of tools. Quite often, one request back to the server is going to result in hitting different sources. You might be going out to your database to query. One is maybe you're going out to Azure Table Storage to get your stuff. Maybe you're making an API call. And in the old model, each one of those would be request and wait, where the async model allows you to go out to them and get on with your life and continue processing. So I think if you're going to deliver rapid nice solutions, you're going to want to start looking at Async if you're not already. Hopefully, you've all had a chance to play with Async some. It's a great tool, and C#, I can't really speak about Visual Basic, but I know C# makes it pretty easy to work with. So definitely look into that. So anyways, you'll notice pretty much all of my calls that we go through here are going to be async calls. All that we're doing here, if we look at the constructor towards this, this is all my code. First off, we're going to go out and we're going to connect to our storage account. The development storage account is an option that comes with it. Comes with their drivers. So I don't need to know what the port is for my local development account. I can just use that particular connection. If I were connecting to something up in Azure, I'd use a connection mechanism closer to what they have up here, where I'm creating a new cloud storage account with these storage credentials, with an account and a key, and the account and key you can get from the Azure portal once you're setting up your location to store these. Then creating a cloud table client, getting a cloud table reference, and creating it if it doesn't exist. And so basically I'm going to go out there and I'm going to create I said boxes before. This is going to be creating a storeroom for all of those boxes called my container. And all that I'm doing is for each of those files that I have, I'm just out here. So the file is just a basic POCO object of representing my file. And I'm simply going out there, doing the table operation and inserting it into there. Now let's take a quick look at the file model here. So when you're working with Azure Table Storage, you have, we talked about the partition key and row key. So this particular object that I have here, you can see it's a table entity, and that again is a part of the Table Storage SDK tool. So it's available through there, and I'm actually defining what my partition key is. In this case, I'm hard coding a partition key to just be images. Normally, you wouldn't do that. Like if I were uploading images, I may have the partition key be the owner, maybe the name of the person that uploaded it. I probably wouldn't do just all one hard-coded partition key because that's going to result in every single one of those images that everybody uploads going in the same place, and that box is going to get pretty full. And then my row key, I'm just creating a new GUID. For what we're using here, new GUID is fine, so I'm just going ahead and creating a new GUID. And the rest of it is just plain old C# properties describing what I'm storing in there. And where'd we go? And so I'm inserting them. And that's pretty much it. So I'm just going to be looping over each one of those, inserting them. Let me remove my breakpoints here. And so they've all been added. The watching the queue, that'll come up in future part of it. But if we look, once you've installed the Azure SDK, it adds a couple of tools to Visual Studio, not Test Explorer, but Cloud Explorer. So it adds this handy little tool to Visual Studio that allows me to look at my development storage locations. I can also look at the server locations if I add in my credentials here. But here I'm just using development, and I can look at the items that I put into those tables. So here's the file entries that we just uploaded. And I'm actually kind of surprised that it has the old data in there too, because I thought I cleared it out, but I must not have. We'll have a bunch of extra data when we get to that point. So it's just dumping the files in there. let me call out a couple of things. Timestamp is an Azure generated field. I can't set the value to that. I can read it, but I can't tell it to put this timestamp on it. It's going to be totally generated by Azure. Partition key and row key are going to be in every single one. The rest of these can be whatever. In this case, I have file name, file description, file add time, and those are going to map up directly to that file model that we looked at a little bit ago.
Where is that timestamp available in the table entity base class?
I think it is. Yep, timestamp.
You also had file added time. What would be the difference? Why would timestamp and file added time be different?
Let's see what IntelliSense says. Nothing.
That's your property down below.
It was your,
Oh, okay. I did add that. That's mine.
so, because the timestamp is when you add it direct.
Right.
Well,
And
timestamp is more the system time.
right.
It's populated by the system, whereas the other file added time is something you can drive.
Right.
Code skews, so timestamp is when you start getting billed.
That I don't think they use it for billing calculations, but that's a good way to look at it. And that's when it's hitting the server and you're getting charged for it. And yeah, you don't really have control over there. So if you want a last modified time or something like that, you're probably going to end up adding that in there yourself. And then from there, I'm not quite going to go to the website because I don't have anything to show you until we start talking about the images or to the blob storage. So let me call out two other tools. There's this nice tool that they have built into Visual Studio once you download the SDK. Microsoft has also started work on a Microsoft Azure Storage Explorer tool, and that's what you see here. It's not quite done yet. As a matter of fact, the only thing that it works for is only one of these works, not queues, images, or blob storage. So they haven't actually implemented the stuff to view what's in your table and what's in your queue in this yet, but that's coming to this tool. Another thing that I'll call out about this is Microsoft developed and it's cross-platform, so they have OS X and Linux versions too. So, and while we are talking tools, another tool, I thought I installed it. Yes. Another tool, it costs about $200, but if you're working in Azure, it's a tool that I definitely recommend. Get your boss to pay for it. It's Azure Storage Explorer, or Azure Management Studio, I guess. Here I have it hooked up to my dev storage again, and I can once again see my records here. So I can see my records from here. I also have a little query interface up there where I can query my records in table storage. And this works with a lot more than just storage. It's actually kind of a management studio for a lot of Azure tools. So if you're using cloud services or something, you can actually get to them through this tool and manage them through there. I don't think this tool actually manages everything available in Azure, but it manages a lot, and it's a nice tool to have if you're working in Azure a lot. So we'll get to reading from tables here in a little bit, but I want to segue over to blob storage real quick. And I'm just going to leave that there instead of switching screens. So blob storage is, think of it as a great big hard drive in the sky. Massively big. Blob storages allow you to store your files in containers. So if we go back to that box model that we had before, you can put all your files into that box. Max file size, 195 gigs. Now, does anybody here have a file that is 195 gigs or larger? Okay, good. If you did, you can always go up to a terabyte for page blob. And we'll talk about the types of blobs here in a second.
If you think database backup files,
Yeah, they can get pretty big. Yep. Does anybody here have a terabyte-sized database that they're working on? Yep. You hear people throw out the term big data a lot. One analogy that I heard is if your data can fit in your memory, it's not big data. So I have 32 megs of memory in my computer at home. If you're less than 32 megs, you're not big data. 32 gigs, yes, thank you. So 500 terabytes per container. 3 types of blobs that are up there. The first 2 types, block blobs, that's a tongue twister, and page blobs were around from the very beginning. A pin blob is relatively new. Block blobs are great for storing discrete files. So if you're wanting to make a Dropbox style clone, you're going to use block blobs. And so you put a file in there, take a file out. Great for storing images, whatever. Page blobs are going to be files with heavy read-write. And if you think of Azure, if you're going out and creating a virtual machine in Azure, odds are that hard drive is actually going to be a page blob. They do have some options now for hard drives based on SSDs. I don't know if those are still based on page blobs, but if you go out and just create a normal Azure VM, you're going to have a page blob backed storage out there. And then you have append blobs. Append blobs are relatively new. I think they just introduced them last fall. But basically every time you write to an append blob, it appends it to the end. And this is going to be great for like logs. If you want to, just log your file onto the end of there, really kind of made for that sort of scenario. And so now let's go look at working with blobs. So I'm going to go back to that same demo that we had before. This time, I'm uncommenting out the portion that works with the blobs. And working with blobs is almost as working with blobs is almost as easy as working with tables was. So once again, we have a list of all my files. Inside the file is the actual file name, and we're just going to loop over that collection of stuff, and we're going to add them to the table, and then we're going to add them to the storage. And so creating the blob. Now, you'll notice I have this. Let me go up to my constructor here first. So I have in my constructor up there, you can see I have creating my storage account the exact same way as I was doing on the file storage. Creating my blob client, and then I'm creating my image container. And again, I'm saying create it if it doesn't exist. This time I also have in that blob container public access type, and I have it set to blob. So basically what I'm telling it to do there is for this container, for this box that I'm creating of stuff, if somebody knows the URL to that file, let them download it. So they don't have to log in. They just have open access to that file, and they can download it if they know that URL. And then the second one, my secure blob container, doing the exact same thing, creating a directory for it or creating a box for it. This time I'm saying turn off public access. don't let, even if they know that URL, they still can't download it unless they have either my storage credentials or a secure access token that we'll cover here in a little bit. So again, really simple. All that I'm doing is I'm grabbing the file, checking to see if it's secure, and again, that's just a property that I set on that file object. And if it's secure, store it in the secure blob container, which is the one with public access off. If it's not secure, store it in the other blob container. And I'm just adding it, saying add it into there, and then go ahead and upload it from the bytes. And so pretty simple to work with your blob storage. Get rid of my breakpoint there. So it'll take a little bit longer because we are throwing around the images this time. Done. Although keep in mind it's only going to my local computer. It's not going over the wire. Probably would have taken a little bit longer if we were going over the wire. Now, let's take a peek at the website that looks at this. So we'll look at the end result first, and then we'll dig into the code behind it here in a little bit. Okay, and I can tell you what happened is I messed up the demo. I had my secret flag flipped. The top secret one was supposed to be secret. All the other ones weren't supposed to be secret. So I had it flipped. If I blame that on GitHub. If GitHub was not down last night, I would have caught that, and I wouldn't have had that problem. But let's take a look at the URL that I'm sending across over there. And I know that this will be difficult to see. So let me just... There. So here's the image that it downloaded. And you'll notice it's pointing to dev storage account, storage container. I guess what I wanted to point out on this is I'm not going through my own application to get the image. Basically, I'm getting a reference to where that image is setting, and I'm telling the browser to go out to the storage account instead of just downloading it from my own application. If this were actually hosted in the cloud, you'd see a dev storage account information there instead of 127, instead of the local host there. But now we have this. Let's look at the code. So again, in my home controller here, all that I'm really doing is I have this call out to my own logic class, and it's simply saying, we're going to ignore the secure one for right now. It's simply saying, let's go ahead and get the URL for this particular blob reference. One of the things that's actually interesting, you notice early on, I said I like to use async for everything. I don't have async in this particular one. Even though I'm getting a reference to that blob item, I'm not actually contacting the Azure server there. It's basically saying, I know what your account information is. I know what the file GUID is, so I can generate the information that's needed to get this file without actually making a call to Azure until the user actually downloads it. So I save myself a round trip there. There is another method out there that will get blob reference from server, that will add on the extra round trip to the Azure server to make sure that the file exists and stuff like that. But I don't have to use that. I can save myself a few network CPU cycles and not do that. So let me go back to, yes, the So here I'm back in my controller, and I got the record to the actual file that I'm working on, looping over them, and I'm basically saying, is it secure, is it not secure? If you remember, the secure ones we put in one storage container that wasn't open to public, the not secure ones we put into another container. If we look at the logic to get the secure one, there's a little bit more code to get the secure one, to get the reference to the secure one than there was for the not secure. Not secure, I could just get the reference to it and get the URI. Where here, I have a little bit extra to do, and this is with the Azure Shared Access, SAS, Shared Access Security. What this does is I am generating a token that is good for a fixed amount of time that temporarily grants users of that token access to this, at an access level that I control. So in this one, getting a shared access blob policy, I'm setting the start time and I'm setting the expiration time. So I'm basically saying allow it to go back a minute and allow it to go forward a minute, and grant them read permissions. I can grant them read, I can grant them write, whatever I need. I can even grant them write but not read, so they can dump stuff there but they can't see what's there. In this particular case, I am, yes. So I can also, if we think back to the box, I can grant them permission to the entire box, or I can grant them permission just to one individual item in that box. In this case, I'm only granting them that one individual item in that box. So, so in this case, I could have hundreds of images in there from hundreds of different folks, and I can still control that only you can see your stuff by properly using these shared access tokens. And then I'm basically generating a URI using that token. Again, you'll notice I don't actually need any server-side calls. So this is just generating it from information it knows about my account, and not actually generating a round trip back to the server. And so now if we look at it, the stuff that was supposed to be secret, and I started the wrong one, we're going to have a whole bunch of images uploaded into there by the time we're done. So now, the secret stuff should be visible along with the non-secret stuff. So here's my images. So another thing you'll notice, all of these images are really big. Wouldn't it be nice if there was some sort of process that shrunk them down so that they actually fit on the screen? Let's look at Azure Storage Queue to see how we can work that in. So first off, what is Queue, Azure Storage Queue? Azure Storage Queue, my mouse keeps on sliding to the bottom. Azure Storage Queue is a really simple queue. Some of you may have worked with like enterprise level service buses. It's much, much more simplistic than that. You put something in, you get something out. Allows you to send a value and receive it in another system. One way that this can be used is communicating with you have part of your application sitting in your data center. It needs to talk to another part that's hosted up in Azure. So you can actually cross the data center boundary and use this to communicate. It's not a full-blown service bus. If you do need a full-blown service bus, Azure has you covered. They have a full-blown service bus. But if you don't need the service bus, Azure Queue is generally cheaper. It's also faster. So this is comparing the Azure Service Bus to the Azure Queue. Latency, Service Bus is faster, about twice as fast. Duplicates, Azure Service Bus will allow duplicates. Azure Queue won't. Delivery order, and I have these flipped around. Yeah, all of them are backwards. So Azure Queue is the fast one. Service Bus is the slow one. Order is not guaranteed on Azure Queue. You put 2 items in, put 1 in first and then 2 in the second. You may get it out, 2 out, and then 1. Where Azure Service Bus has the option to have delivery order guaranteed. Azure Queue, time to live, is 7 days. You put a message in there. If you don't get it out within 7 days, it's going to disappear. Azure Service Bus, that's actually configurable. You can say, I want it to live for 2 minutes, or I just want to leave it in there until we pick it up and do it. Then max queue size, costs. It's actually kind of interesting how they're billed a little bit differently when it comes to the cost. I imagine that's because Azure Queue is built upon the storage infrastructure, and so that's why they're charging you based on the amount that's in there, where Azure Service Bus, you're charged X amount per operations. But either way, you notice that 7 cents per gigabyte, you can send a lot of messages at that rate. Even if you're going up to the Service Bus, 5 cents per million operations, that's a lot of messages.
Right, do you know if there's a difference in the way that the network traffic gets built between those two?
There probably is. And that's one thing I haven't talked about a lot is your network traffic to there. I think this is still the case, that if you're dealing with traffic inside the Azure data center, you don't get charged for any traffic. But as soon as it leaves the Azure data center, the money starts running. So in your case of your web application is talking to table storage, if they're both up in Azure, table storage can talk to, or your website can talk to table storage all at once for free. But as soon as you send that response down to the user, you get charged for it. But it's a small charge. You can send a lot of stuff. But that does mean, like, if you're writing an image application, you're going to get charged for the images going up into Azure. So another error that I would have caught if GitHub had not been down last night. So let's look at what we can do with the queue. I'm going to stop this. So, and I'm also going to delete these because I want to make sure that we get all of these items in the queue so that things are handled correctly. And we'll do the same thing. So it's going to run through the table service, run through the storage, and then it's going to hit our queue. I want to make sure that we hit this one too. So again, we're just taking that reference to the file, file that we've now put in table storage. We put in Blob Storage, and we're simply going to take that message, take that item, and put that file's ID in the queue. Now, in this case, I don't need the entire message in there. I certainly could put the entire message in there. So if I wanted to take that entire file object and serialize it and put that whole thing in the queue, I certainly could. But in this particular case, the only thing that I really need to send a message across is that ID. And so if you're thinking, if you think a web application, say users upload these images, we want to let them upload the image and get right back, send the screen right back to them. We don't want them to have to wait while we're processing the image. So we're doing this nice quick operation of dropping the message in the queue, and then something else is going to pick it up. So here I'm just going to loop through all of these and drop all of these messages in the queue. And I don't know. Okay, so we've done uploading it. Now, in this particular case, I have the same executable watching my queue, but this could easily be another process. A common worker role is if you're up in the cloud, you'd have like an Azure worker role that would set out there, and it would do nothing but listen to your queue and process images off of it, or process work items off of there. So all that we're doing is processing these images, and because I didn't want to put a bunch of logic for my queue or for my table and my file storage into the logic that handles the queue. I have the image processor that kind of sits in between of them, and it defines this function in here that I won't go through this entire one, but it takes an image ID, gets that reference off of the Azure table, gets the actual file, and it resizes the image down for me. And so all that I'm doing is I have this handle new messages asynchronously that takes a func of string task bool. And so basically what this is saying is this particular function takes a string parameter and it's going to return a task, which is used in asynchronous programming, of bool. And that image or that function that I'm passing into there is from this from this earlier one. So basically I'm just passing this function into the service that processes new messages. And all it's going to do is pretty simply it's going to get the message from the queue and pass it onto that function that resizes it down and then dumps it back up to the table storage. And then an important note is it actually deletes the message off the queue. So if I left it on there, it'd just forever process the same thing. So from here, it's going to go through the messages on there, and it's just going to sit there waiting for new messages. In this case, there never will be any, but it'll wait. So now if we look at our website, and at this point, there's no new logic in the website. It's grabbing the same reference to the image, but now our worker that was powered by the queue has resized all of these down so that they actually fit on the screen. So there you can see how a queue can help your workload. I have one more demo, but any questions on any of the things I've shown in this one? The top secret was supposed to be top secret, but I had them flipped around. All right. So the other demo that I have is actually built on, and I kind of did this out of order. This is just table storage, but it shows a couple of tricks for working with Azure table storage. Let's bump the size up. So one of the things that I'd recommend, if you're gonna look at using Azure table storage, because of some of the challenges that we talked about earlier with shaping your data and making sure that it's performant, I'd actually almost recommend building out a test harness to test your theories about your data. And that's exactly what this is I basically wrote a tool that loops over. I can tell it to basically for every day, for however long of a period I put in there, go out and create records for 2 users in this case. And so the idea was I could massage these tools and I could say, okay, I want to see how this data structure would perform if I had ran it for a year and I had 10,000 people using it. It takes a long time to put that many records up there, but it's certainly worth it to go ahead and test your theory out like that to make sure that you're not gonna get a certain number of users in there and then your queries start running slower and slower. So
you find that the development's emulator performs scales?
When I was actually running this test against, so I'm using something similar to this in a side project. When I was using this to test it, I tested against the actual Azure one. And I mean, I loaded it up with enough data, I started it and let it run overnight and checked it the next morning. So if you're using it for testing how well it's going to perform in production, I don't know that the local emulator is a good test because it's not built on the same infrastructure and tools. So
There's no SQL server underneath the
right.
Azure Data Center
Right.
service.
Nope. Yeah, your local one is, and there's actually a schema you can look as it's running and play around with it. But yeah, the one up in Azure, no SQL. So, I you know, because it's going to be a lot easier to identify those bottlenecks now than it would be 6 months from now. And now I have all of my data in the wrong shape. So I'm going to have to write a console application to pull it out and reshape it to the shape that I think is going to work. And, you know, so if you're going to go with something like this, it pays to do a little bit of testing. Not saying you have to go 10,000 users for a year, but definitely do some sort of test to make sure it behaves like you think it would. The other thing that this application shows is the ability to store data of varying sizes inside your tables. So what I'm storing in here is look at my create entries. So this is still using the base Azure SDK, but it's using it in kind of a creative way. So what we're storing is biometric data. So we have blood pressure and this biotrack entity or biotrack entry is just another PO code that I created. It's a table entity. And I have a data type on there. I have entry time, the ID, just a GUID, user ID, and entry body is just a dictionary of 2 string values. Now, and if you look, the next entry that I have is weight. It's just 2 string values, but they're 2 different string values. The third type that I have on here is body measurement, and it is a whole bunch of different values. So you can kind of see none of these, if we were looking at like normal SQL database, none of these are the same type of things. You wouldn't normally put them together. However, we can put them together with this. So if I look, so here's that entity that we were talking about. It's just a normal table entity, but I'm overriding a couple of methods on this table entity. One is read entity, and one is write entity. And basically all that I'm doing is I'm going over that dictionary, that string dictionary, and for each one of those, I am adding to my base entity, the entity that's going to get written up to Azure, splitting those 2 out, and I'm saying this is actually a field in that entity that I'm going to store up there. So it's pulling that dictionary out into basically properties to look like, it's making that dictionary look like just another date time, just another ID, entry category ID. And then when we read it, once again, I'm overriding a method in there, but I'm basically doing the exact opposite. I'm taking those column values and I'm collapsing them back into my dictionary. So let's let this run, and then we'll look at what the data looks like when it writes it. And so this is actually running a lot slower than what I would expect it to, again, than going against the real one. Okay, so we wrote several values out there. I think we wrote 5 days worth of values for 2 users. So if I go back into Cloud Explorer, now we can see we have the same old, and I know you guys probably can't see that all that well back there, but we have our partition key, our row key, our timestamp, entry time ID, user ID, data type. So all of those are so far nothing out of the ordinary. But you'll see when we get into like blood pressure has diastolic and systolic, but it doesn't have weight, units, neck. If we could actually look at how Azure is storing this up in their cloud, they're not storing these extra columns up there. It's not like if I was storing this in Azure or in SQL Server and I wanted to make just a single table that stored all of these, I'd have a whole bunch of nullable values out there, and it'd be null for weight, it'd be null for units for blood pressure. And so I'd be wasting a bunch of those system resources, where Azure Table Storage is smart enough to say, nope, this particular entity is only needs these columns, so I'm only going to requisition storage for these particular columns, and these other ones just don't exist. And then weight. Here we have one where, I shouldn't have done that. Body measurements and weight both have a units of measurements, so they actually both share the same thing. But again, the Azure Table Storage doesn't care. And so you can kind of picture how I can store different types of entities in the same one to kind of get around some of that creative thinking that I was talking about earlier. Just for your information, the model that I actually ended up using, I store this data 3 times projected out to different shapes all in the same table. So that kind of gives you an idea of some of the stuff that you can do to to get it in the shape and format that you want for consuming. All right. And we've gone through all the ones. So is there any questions that anybody has on any of this?
Is that a standard that you've read about or heard about where you do store the data multiple ways for that reporting or consumption?
I think the web is heavily read. So typically in a web model, you write your data once and you read it a whole bunch of times. And so it's just optimizing it for reading it. And there is a Microsoft page that talks about shaping your data to work with Azure Table Storage. And they do talk about shaping it in a way that is read optimized, if your model is read optimized. Now, if I was storing logs in here, I wouldn't necessarily care about making them read optimized because we don't read logs, we just let them gather dust and, So, but yeah, thinking about how you're using your data and shaping the data accordingly is kind of key to making this work for you.
Brian, what about data types though? In your table entity, there's nowhere where you actually say this will be
Right.
data types such and such.
Right. It is typed. So in where did I get to? So, oh, but I'm in the wrong project is why. Did I close? I must have closed the other one. So in the one where I had the dynamic column widths, I was using just string, so it's going to use string. This one, it actually knows to read. It knows about the data in your table entity, and so it's going to actually store this as a date time in there. It's going to store it as a bool. I think it probably stores the URI as a string. It's got half a dozen date types that it actually stores them as. So.
Does it throw an exception if you try to read it as the wrong data type, or try to deserialize it as the wrong data type?
It'd probably throw a client-side exception, I would imagine.
Yeah.
But yeah, I think it would.
So what about binary or geography type data? Is that
Well, I have seen there was an interesting article that I had came across, and
because in your example, you store the binaries of the images in Blob.
over in Blob, right?
The data in the table.
Right. Yep. Yep.
You might get the idea to actually maybe the smaller images store them with the metadata in the table.
Right. And although there is a length limit to the table, so you are limited. I don't remember off the top of my head what that length limit is, but there is a length limit that you'll hit. There was one project that I came across where the individual, and this was just a purely for fun sort of project, but he was basically serializing his objects and storing them into the table storage, but in a way that had intelligence behind it so that if it was too long, it would span multiple rows in there. And it seemed like way too much work. I'm just like, just put it in the blob storage where it belongs. So yeah, geographic data, that'd be interesting. Yeah, that'd be an interesting one to take on here. I mean, you could easily store like points and stuff like here, but once you got out to complex shapes and stuff like that, it'd be interesting.
Yep.
Ryan, with your biometric data, that'd be an example if you're reading it of one of the least efficient methods for retrieving it, right?
Depending on how you're retrieving it, yes. So let me pull that project back up. Actually, I guess what I was going to look at.
where I'm going with that is that would affect your design, your table design from the get-go.
Yes. And okay, so trying to remember. I think the way that I put these in here, I have user ID, and then that is the day. So I have user ID, which is GUID.20160125. So it's the day broken down. And this would be efficient if I wanted to, say, get all the user's data for a certain day, one user's data for one day. This would be efficient for that sort of read. If I wanted to say, get all of this user's data of this type for the last week, this would be really inefficient.
So in that case, would it be considered okay to store the data multiple times in different ways?
Yeah.
Okay.
Yep. And if you're going to be storing it, and in the presentation, I didn't really talk about this. So we have these entity group transactions. That would be something where you might want to store them on the same partition and write all three, so let's say ultimately you're going to project it out to 3 shapes. You might want to write all 3 of those at the same time to the same partition inside an entity group transaction so that you didn't end up in a situation one worked and the other 2 didn't, and so.
So can you do any aggregation then? Within an atomic operation, so I want to sum up.
You can,
Partition.
depending on what you're doing with it, though, it can result in table scans. So again, it's going to depend on what the shape of the data is and how you're wanting to query it. But yeah, it could result in if that aggregation is having you ultimately do one of those inefficient styles of queries, it's going to result in a table scan. So
That's really there's no indexing.
right,
You really have to look at the partition key and the row key
right.
and an intelligent order or shaping of the file.
Right, and so maybe one way, let's say you are, let's go back to my biometric entries, and let's say I wanted to calculate the average of all of my blood pressure entries. What I might do then is I write it. At the same time I write it, I send off a queue message, and for this I probably actually use the Azure Service Bus, step up to the real queue. Write it, and then I have a worker process that will read that message, and its role is to do that summing. So it would go and look at, it would do the inefficient queries on the back end, sum it up. Now it's in there in a shape that you're able to read rapidly.
If you call that out, there's no query against the query function.
There is some query functions behind there. Like if we go to that Azure Management Studio where it had that query interface. So it lets you do a link style query. And I think it's actually OData is how it's actually talking behind the scenes. But I believe that if you write that query and send it, it's sending it server side. But the server is just going to be doing table scans depending on what sort of shape your data is in. So, yeah, shaping your data if you're using Azure Table Storage is definitely the biggest challenge and the highest barrier for most scenarios. But if you have something that can fit into there, if you can make it work, you can save a lot of money by doing that.
You probably don't have to worry about thrashing Microsoft's hardware either, right? I mean, if you want to issue an inefficient query, you don't have to, again, a SQL Server database, you'd
Well,
be concerned about affecting the performance
right.
of the overall database. In this
Yeah.
case, it doesn't really matter.
I don't know what would happen if you had a really inefficient design and let's say you had a worker role that was just hammering it nonstop. I don't know if Microsoft would call you and say, what are you doing to our servers? It's probably spread out over so many servers that they probably don't even notice it. And one of the things that they use to spread it out over servers is that partition key. So if it's all in the same partition, I believe it'll all set in the same server.
So you're only hurting yourself.
Although even in the same server, depending on what level, this is another thing I didn't talk about, but all of these storage items, there's redundancy options on them from the lowest level that is redundant to the data center up to geo-replicated. So geo-replicated would mean like if I write this blob entry in the east data center and I have it configured to geo-replicate to the west data center, as soon as I write it in the east data center, it's going to get written over into the west data center too. Behind the scenes, I don't have to do anything. It just happens. And so when the east coast gets buried under another foot of snow and their power goes out, I can go to the west coast and get that same data. So, of course, that's extra.
As long as your plan supports it.
Yes. As long as you're willing to pay for it. And it does start to go up quite sharply once you start doing that geo-replicated for their stuff. So, cool. Yes.
Have you had experience migrating from a relational database to table storage? And what are the challenges associated with such a migration?
I haven't, but I would imagine it probably involves like writing a console app to do the migration. There might be SQL, I can't remember what, SSIS tools that can write to table storage. I don't know. But if I were given that task, knowing what I know, I'd probably start off with console app to read the data and write the data.
So would you have to figure out how to map between tables and write your own logic?
Yeah, I think you would. I think you would.
You'd be starting out with denormalizer from the get-go.
Yep. You'd basically write a query that flattens out your data and then just loop over it and throw it up into there.
At the end of the day, this is basically just a hosted NoSQL database, right?
It's a really simplistic NoSQL database. And Microsoft now does have a more fully functional NoSQL database with their document DB. And that's got more of what you'd expect from a full-blown NoSQL solution. But it costs more. So yeah, I think the main selling point, even though there's a lot of challenges working with table storage, is the cost savings that you get. There's not as many challenges of working with blob storage. That's a give me. If you have files that you want to store up in the cloud, throw them in blob storage.
But the main question is, does it export to Excel?
You can write a program to export to Excel. I don't know. It wouldn't surprise me if this tool exported to Excel. Yeah, I don't know.
File say that?
Download, there's a download option there.
Where do you see download?
Table, there's right click on the table again. Download.
Does that carry the
There you go.
CSV or XML. But yeah, you could write a tool to export it to Excel.
It's a copy paste. True.
That's 7 cents per million.
Yeah. Cool.
One more thing.
Yes.
Comparing it to Apache Cassandra, like with the key spaces, this is pretty much the similar concept.
I haven't worked much with Apache Cassandra, and by not much, I mean I read a couple of articles on it, and that's about it. So I don't know. I would imagine Apache Cassandra is probably more advanced than this one is. Cool. Well, if there's no other questions, another thing that Matt and I have kind of talked about and we've decided to start doing is how many here listen to .NET Rocks occasionally? So familiar with their Better Know a Framework segment that they have? In it, they just talk a little bit. It's a little bit that they do right at the beginning of each of their podcasts where they just give a minute introduction to something out of the .NET world.
Something obscure that you
Yeah.
don't really work with too much.
So just a chance, something really quick. Maybe you'll learn something from it, maybe you won't. So we're going to start doing this at the end of every presentation, right before we do the drawings. And Matt or myself will come up with topics, but we also want to open it up to you guys to come up with topics. So if you come across something, you don't want to give a full-blown presentation, but you think, oh, this would be really cool to share with the group, reach out to Matt or myself, and we'll get you put down for one of the months, and you can share it with the group. So since I'm just now telling you about this, I went ahead and chose one for this month. And the tool that I chose, and I kind of named it, if somebody has a better name, I didn't want to steal Better Know a Framework, so I called it Tips, Tricks, and Picks. 2 minutes in the style of .NET Rocks Better Know a Framework. So the tool that I picked is called Edge.js. And I've been working with JavaScript quite a bit. I still love working with .NET, but these days I probably work with JavaScript more than I do .NET. Edge.js is a quite amazing tool. It will allow you to run .NET code in your JavaScript or JavaScript in your .NET code. So it's a way that you can kind of bridge the gap. One area that I think is really interesting, let's say that you have a form, you're probably using JavaScript for client-side validation of that form, but you don't want to go and repeat writing all that validation logic in .NET. So there's certainly tools in the .NET framework that let you mark up your objects with metadata that will generate client-side validation. But using this, you could actually leverage something that would use your .NET code would use your JavaScript validation logic to validate that same stuff. So just an interesting tool that maybe you hadn't heard of, maybe you have. So. And yes, that is it.